Hi everyone and welcome to the second video on the entity relationship model. In this video we're going to learn about two new constructs in the entity relationship model which actually make it the extended entity relationship model. The first construct is something called weak entity sets, also known as existence relationship. Remember, a relationship is a diamond, so the existence relationship is a special kind of diamond. And the second thing we're going to learn about is subclass entity sets, which is also called the generalization specialization hierarchy. This is not a diamond, this is different from a diamond, and is actually represented as a triangle. And we'll learn more about this hierarchy also. So let's get started. So let's start by looking at two different entity sets, each of which represents a separate set of things. So an example might be a set called banks and another set called accounts. So obviously a bank is not an account. There are different things in each box. Now each box has its own intrinsic attributes and its own linked attributes, which as we know are modeled as relationship sets. So here are some example intrinsic attributes for accounts, and here are some example intrinsic attributes for banks. So obviously we want to link the accounts to the bank to which they belong. So we have two choices. The first choice is what we already know, which is a standard relationship set, uh, like a diamond that we know, because this is a linked property of an account, right? The bank that it belongs to. And so we would just do a diamond out here, give it a name, and we would have the cardinality here, which is for each account, there's a minimum of one bank and a maximum of one bank. And on this side, for each bank, there's minimum 0 accounts, maximum n accounts. These are, of course, the intrinsic properties of accounts, and these are the intrinsic properties of banks. Now, here it's important to note that the accounts in the accounts box are identified uniquely by their primary key, which is the account ID, and the banks in the bank box are identified by their primary key, which is the bank ID. Okay, so we looked at accounts as belonging to a bank in the previous slide, where each account sort of existed independent. It was linked to a bank, but it had its own account ID. But sometimes in user requirements, this may not be the case. So let's take a different example. Let's say that accounts belong to banks, and if a bank uh, dies, in other words, it's removed from the box, if a bank is removed from the box, then all the accounts that are linked to that one bank have to also be deleted. This is what we call an existence link. In this case, the accounts cannot be transferred to a different bank. They have to only stay with that bank. And because each account stays with one bank, the account ID is not enough to identify the existence or the identification of that account. We also need the bank ID. So it's possible that within two different banks, you'll have two accounts, each of which has an account ID A1. But if you take the combination of the bank ID and the account ID, then we will be able to uniquely identify the account. So this happens in an existence diamond because the account needs the ID of the bank for its existence. If it did not need the ID of the bank for its existence, then it would exist independently of the bank, and it would not be, of course, an existence dependency. Notice how we show this existence dependency. It's still a diamond, but it's now a double diamond. Notice that you have two lines out here that go to a double box. So this double box is now called a weak entity set. It's different. The objects in here are different from the strong entity set objects. Accounts are not the same as banks. They're different. Of course, the weak entity set can have its own associative links with other entity sets, but it's weak because all the entities inside this box their own ID is not enough. This ID needs to work with the ID of the strong box in order to uniquely identify each account in this case. So as we said in the earlier slide, you have a double diamond. It doesn't have a name because it always means the same thing. It just means an existence dependency. It's different from an associative diamond, which each one is different and you want to describe the nature of the association. In this case, the nature of the association is existence. We know that. So we don't need to name this. This cardinality has to always be 1, 1 because by definition, each account, for example, in this case, is dependent on one and only one bank. And this could be 0 many or 1 many or whatever numbers you want out here. Now account ID, when we draw the diagram, account ID has a dashed line now to show that it's a partial identifier for the account. In some books it's also called the unique identifier because within a particular bank it's unique. All the account numbers are unique, but across banks they may be duplicate. Okay, so we are finished with the existence dependency, which is modeled as a double diamond. Now let's move to the subclass superclass hierarchy, also called the generalization / specialization hierarchy. This is different from a diamond. A diamond is a relationship. This hierarchy is modeled as a triangle. So it's not the same as a set of links. So let's try and understand now what this hierarchy means. So let's start out by looking at any entity set. We know that any entity set is a collection of things where all the things in the box have the same set of intrinsic attributes to describe them and the same set of linked properties as well that are shown as associative diamonds. Now it's possible, of course, that some entities in the box, some things in the box may not have a value for particular attributes, and or they may not have links into a particular diamond. This is fine. For example, not every student needs to take a course section. Not every professor needs to have taught a course section. So all of that is fine. However, another situation can arise. If all the entities in the box may have common intrinsic attributes, but they may have extra attributes that may be relevant only to a subset of the entities in that class, also called a subclass. So if we have a box, we can take a few of the entities in that box that form a special subclass. And why is it special? Because it's described either by extra intrinsic attributes and or extra linked properties. So we call these specialized properties. So here's an example of a big box called the students box. And of course, we'll have the student attributes. We'll have student ID, which is the primary key. We'll have the GPA, we'll have the name, we'll have the email, we'll have the address, and so on. But let's suppose that within this box there is a small subgroup or a subclass called grad students who have extra intrinsic properties like their undergrad major, their undergrad institution, their undergrad GPA, etc. It's important to note that grad students still have all the properties of a student. So their primary key is still the student ID, but they've got these extra intrinsic attributes. Further, let's suppose they also have linked properties that only relate to them. Like, for example, they are linked to course sections in a link called TA for teaching assistant. So this would be a diamond that would only be applicable to the grad students within the students box. So here's a rule of thumb. If a subgroup within a box has at least two specializations, either intrinsic or linked, then what we're going to do is we're going to project this subgroup using the triangle. We are going to project the subgroup out of the box and list the extra intrinsic properties and the linked properties that are specialized for that subgroup. So let's see how this is done. So here we have a rather complicated diagram. So let's take a look at it. We have a box called students. All students have these intrinsic properties, including the primary key. And then we have a projection from this box. The is/a simply means that a credit-seeking student is still a student, that a continuing ed student is still a student. So we are doing this projection here because the credit-seeking students have two extra specializations, which are in this case intrinsic attributes. And the continuing ed students also have two extra, at least two is what we need. So in this case, they have two extra intrinsic attributes. And then further within the credit-seeking students, we have a further projection because you've got grad students who have all of these intrinsic attributes that only relate to grad students. And they've also got this linked attribute that only relates to grad students. And here we have undergraduate students, which is another projection. And these intrinsic attributes relate only to undergrad students. So take a moment to look at this whole diagram. You can also see a weak entity set here called course sections, which is a weak entity set of courses. So try and think of what that means. In this case, the course section ID is not enough to identify the course section. You also need the course ID to go with it. And here you can also see that there is a link between course section and students called take with an attribute grade. And there's another link between grad students and course section called TA with this attribute here for the diamond. So take a moment to make sure you understand this diagram. So this video concludes all the constructs that we need to learn in the extended entity relationship model in order to capture the deeper meaning or the subtle meaning in natural language requirements like English that are given to us by end users. So once again, the ER model is not really shown on computers, unlike the relational model, which is the table model, which is the one that we use to actually store the data on computers. However, the ER model is a semantic data model, and it allows us to sketch requirements and then, of course, later on map them to tables. So as a fun activity, try to extend the ER diagram that we just saw of a university. Add the concept of rooms. So you have rooms, but then do you want to create subclasses of rooms like classrooms or offices? Remember, you need at least two specializations to create a subclass. Where would these rooms be linked? Would they be linked to professors? Would they be linked to course sections? And then also you can have a box called buildings. And then you can think about each room and how it's linked to a building. Is it an existence relationship? It would be an existence relationship if a building is removed from the buildings box, then all the rooms associated with that building have to go away. And secondly, because of that, each room is identified not just by its own room ID, but also the building ID. If these two things are true, then you've got a candidate for a weak entity set in rooms. And of course, as you do your diagram, don't forget the cardinalities for the diamonds. Have fun with this, and we'll see you the next time.